Hello, I'm Tyler Henricks. I'm a student in CSE 3200, and today I'm going to be going over Chapter 6 in the textbook, which is on testing. So first, I want to talk a little bit about. So first and foremost, we want to be able to formally verify the code in our app. So, it's possible to just run the app and test informally whether what we have is correct, but we do want to have some formal way of verifying that our functionality is correct. Also, the method I just talked about involves building and deploying the app over and over, which can be time consuming as we have to build it and then run the emulator. So this overall can take a significant amount of time, and we want to reduce this. So it is possible to verify the functionality of just pieces of our app in a more standalone way, which we'll get to soon, is called unit testing. And furthermore, we want to be able to do regression testing, which basically this means whenever we make changes to our app, we want to verify that the app works the same as before we made those changes. And this is particularly relevant when we are making changes to pieces of code like classes we have already made in the past and we have already had significant changes to now. So you want to verify that the app works the same in those cases. So there are two main types of testing. We have first JVM tests, which is also known as unit testing. JVM stands for Java Virtual Machine, as I was saying before, this is where we're going to verify the behavior of a specific isolated unit of code in the app. And this is the faster type of testing, given that we don't need to actually run an emulator or device in order for this test to run. And in that case, it is best for testing code that doesn't need to interact with the Android SDK. That's what brings us to instrumented tests, which are actual tests that execute on the device or emulator. And because of this, they are more accurate, and it is the only way to actually interact with the Android SDK in a traditional sense. There are some workarounds that we can do, but in general, if we want to interact with the Android SDK, we want to use instrumented tests. However, this type of testing is slower due to the fact that we have to run an actual device or emulator in order for these tests to run. So in this little video series, I'm going to be mainly going over JVM tests, which, as I said before, is also known as unit testing. So we're going to be using the JUnit testing framework, which is the most popular unit testing framework for Android development. However, the book does use JUnit 4, but JUnit 5 has since become available. This will require some additional setup in the Gradle file, but we're going to use it as it is the accepted standard right now. And really the only use for JUnit 4 moving forward will be to basically have a way to run old tests from legacy projects that still have JUnit 4. But there are many ways now to migrate it to JUnit 5. However, the code we will write, the actual tests that I'm going to be writing in the next video when we go over the demo, they're not going to be very different from the book at all besides some import statements, because these tests are going to be simple, relatively simple, just as an introduction to the topic. But JUnit 5 does have additional functionality for more advanced testing, and these two links below you can visit if you want to see some examples of what JUnit 5 can do and why it's going to be the accepted standard going forward. So now I want to get a little bit into what actually tests are and some of the conventions for them. So we can find tests, and we're going to build tests inside of the test directory that can be found, and I'll show that in the next video. JUnit tests are encapsulated by classes, so we're going to make a class and put all our tests for one specific thing or one specific class that we are testing inside that test class. Inside that class, we'll have functions, which are the actual tests, and they're going to be marked with the @test annotation, which basically just tells the compiler that they are tests. We're going to want to make sure that the names are quite descriptive so we don't have any ambiguity with what we're actually trying to test in that case. And also the testing class name, we just want to relate it to whatever class or piece of code we are testing. So basically, if we're trying to test a main activity, we'll make a main activity test class where all our tests that have to do with main activity, those are going to be in that file. Also, we do have one default test provided by Android, which is the example unit test, and I will be showing this in the next slide. So as you can see on the bottom, we have the basically a super simple unit test right here. It is example unit test. That is a class, and as below, we have the @test modifier around a function saying addition is correct and an assertion in there. So the assertion is an important part of testing, and as we can see here, we have an assert equals, which basically just tests the condition that the expected value, which is the first parameter, is equal to the second value, which is the actual or thing that we are trying to test. So as we can see, that is one of the conditions that we are trying to test, and not shown here, but there is an optional third parameter for a message, which basically this just means if the test fails, we will output that message, so we get a more verbose statement on what is actually going wrong with the test there. In a test, in a function that is our test, we can have multiple assertions, and basically the way that this works with multiple is if any of the assertions fail, the entire test will fail as well. And now I'm going to get into a demo in the next video where we're going to see these more in action.